Okay, to begin the experiment, we need to gather some equipment. Some of this will be provided by the stockroom. Some of it will be in your drawer in your lab. All right. So let me fix my goggles here. All right, here we go. So from your lab stock locker, you want to get a spatula. You also want to get, actually, you want to get several spatulas just to avoid contamination. You're also going to need to get a few of these 6-inch test tubes. You're also going to need a watch glass. And notice that I've placed pieces of tape at about a 120-degree angles from each other. And what we're going to do is we're going to label those A, B, and C. Okay, I'm going to label these A, B, and C, kind of like that. All right, that's how they're going to be labeled. And that's what you're going to use to mix your substances. The stockroom is going to provide you with a little container full of these capillary tubes, and let me show you what they look like just so you know which end is which. And hopefully the video camera will be good enough to pick up the difference here. You'll notice that the capillary has, let me put a little contrast, one end that is closed and one end that is open, all right? So make sure that you realize there's two ends to it and expect it. Make sure that it's not broken and that there's a hole on both sides, okay? And then the last thing you'll need is a long glass tube that looks like this, and I'll show you what that is for in a few moments, all right? All right. This is the easy melt apparatus that you're going to be using for today's study. One important thing is, you see this yellow button here? Please never touch that button, because if you do, you're going to alter the calibration of the instrument. The buttons you're concerned here with are the start button and the stop button. And also, after you've collected your data, these three bottom buttons that are in here. All right? To start the experiment, we're going to bring the easy melt to our starting temperature. The instrument has already been calibrated, so if we simply press start, you'll see the heating light go on and the operate light go on. And now what's going to happen is the machine's going to start heating up to our starting temperature, which is going to be 110 degrees Celsius. That will be the starting point for all of our samples. This is the way that your watch glass is going to look like after you have placed your samples in. The stockroom will have given you a fairly larger pile of your unknown, and that's what I'm going to put as A. That's going to be sample A. Now, samples B and C do not refer to the actual compounds. They actually refer to the mixtures you're going to make. So with your designated spatulas in the area where the candidates are, you take just like the little tip of the spatula, you can see it there, and bring over one sample of one compound and one sample of another one. In my case, I have chosen trans stilbene for my mixture B and succinimide for mixture C, and this is going to be my unknown here in A. Notice that I put a piece of tape underneath to kind of fix the watch glass in place so it doesn't roll around when I'm dispensing or manipulating these things. I already made the mixture B here, so let me show you how I did that using the mixture for C. So what you want to do is, with your spatula that you have designated for your unknown, you're going to take a little bit, maybe some of your sample here, and move it over here. Just squish it over here. And then let's move it a little more so we can give ourselves some space and avoid contamination. And then with a different spatula, you're going to take a little bit of your, in this case, your compound that you're choosing for mixture C. Notice it's just a little bit of it. Your lab manual might say a ratio of, I don't know, 5 to 1, 6 to 1. I usually do like a 9 to 1 ratio because of experiences we've had. And now that I have it in there, what I'm going to do is I'm going to mix them. Please don't get any bad ideas of what I'm doing here. All right? No, it's not that. This is just compounds here. All right? Let's mix them up. And I'm going to now put them into a little pile. Notice that it's very similar to the pile that I had here for B. Again, remember, B and C are not the compounds. They are the mixtures of my unknown with two of the possible candidates. Now that I have my 3 mounts, I need to prep them so that I can load my samples onto the capillary tubes. So for that, I'm going to use a 6-inch test tube, and I'm going to use it essentially kind of like a pestle in a mortar. So let's say I'm going to prep my unknown here. So what I'm going to do is I'm going to basically squish it very carefully. In other words, you don't want to tap on it. You want to touch and then squish, touch and squish. Help yourself moving it around, making it into a pile, right? And then squish it and squish it and squish it. What you want to do is essentially almost pulverize the crystals into very fine particles, because that'll make it easier to load on your capillary tube and then observe it. All right? So I'm going to keep doing that. Now what you're going to do is with a clean test tube, do the same thing for the B mixture and the same thing for the C mixture. All right? Now that we have one of those, let's go ahead and see how we load our capillaries. So again, remember that your capillary tubes have two ends, right? There is an open end and there is a closed end. So you want to put them with the open end facing towards the pile here. And then what we're going to do is we're going to dab on that pile several times. And so we can grab a few, a little bit of the sample. So dab a few times, kind of squish it in there several times. If you need to, remake the mount here so you can get a better sample. So a few times here, you can see how it's filling up. And now that we have it ready, we're going to do something else. So let me take you to another station so you can see what we're going to do next. Okay, so now what you're going to do is you want to get this long glass tube, put it on top of your bench, and now bring in your capillary that you kind of semi-filled with some stuff there. Now invert it with the closed end facing down now, all right? And now what you're going to do is very carefully drop it down this tube. Let it bounce a few times when it falls down here. Okay, you may have to do 2 of these drops. All right, so we have a few of these drops, and as you can see now, the sample is compacted in the bottom of the capillary tube. And now we are ready for the next stage. A couple of things to point out. Number one, you may have to go and dab some more of your sample into the capillary tube. You would like to pack about a little under a centimeter's height of sample. Once you have done all 3 of them, what you'll do is use a piece of tape and essentially make little banners to identify what each tube was, A, B, and C. And you'll notice the samples in the bottom, about a centimeter or less packed in there. Be careful when you are making your samples that you don't get things contaminated. In other words, make sure you don't get mixed up which tube has what mixture. And again, let me repeat. Remember, B and C are not the compounds that you chose as possible candidates. They are mixtures of one of those candidates with your unknown, which is A. Now that you have your samples packed, let's go put them on the easy melt and see what our next stage is. Okay, we're back here at the Easy Melt, and you can see that the temperature is now at 110. And you'll notice that the light that says Insert Samples is now on. That means you're ready to load your samples. On the top of the machine, there are these tiny holes into which you can fit these guys. And you should fit them in order A, B, and C. So I'm going to put A. I'm going to put B in the next little hole. And then I'm going to put C. Just make sure they're fully inserted, even if at this point you might not be able to see all of the little flags. Okay? And there is a window here with a magnifying glass. Unfortunately, because of the bright light and the poor quality of my camera and not having a good filter, I'm probably not going to be able to show you that, but we'll try it out. Once you have started, you want to wait about 30 seconds. It may be that one of your mixtures, you put too much of the known compound in with your unknown, and so it's going to cause the melting point to drop so drastically that you're going to end up with the substance, or the mixture the mixture already melting before you even start the procedure. Okay, so we're going to look at this here for about 30 seconds, inspect, make sure that the substances inside the mixtures are all solids. Again, you'll notice that based on simple physical appearance, you cannot tell these three substances apart from each other. I mean, the mixtures I made between my unknown and then the transstilbene and then with the succinimide, they don't look any different because physically they have similar appearances. They also have very similar melting points, which means that getting a good measure of the melting point is not going to be enough because they are going to be within percentage difference of each other, which is not enough accuracy to ascertain that the compound we have is one or the other. Once we're ready, I'm going to click the start button, and what's going to happen is the machine is going to start heating, as it says here, melting, at a rate of about a couple of degrees per minute. The temperature is going to be rising, and what you want to do is you want to observe inside the window. The progression of the melting is as follows. At first, the sample starts looking a little shiny. Maybe it might kind of resettle a little bit. At that point, be ready, because as soon as you see the first tiny little droplet form, you're going to be hitting the left or center or right button here to capture that data. You also need to tell your teammates, C is melting, so that they can write it down from the temperature here on the display. That way you're going to have two sets of data. One set is the one where you read the temperature and record it on your data sheet. The other one is the temperatures that are captured here. And the idea is that one or the other, you miss it, you can always come back and check it out. All right? So let's say at this point that sample C is starting to melt. So I'm going to say melting C, and I'm going to click this button here, and it's going to capture a data point in there. All right? So this is kind of like the way the experiment works. The next stage will be when the substance melts completely, and at that point you'll say freezing B or freezing Z or something like that, and then you'll click that button again. So you're capturing two sets of data in here. One is for the melting point, one is for the freezing point. And remember, we're not actually waiting for the substance to melt and then refreeze it to calculate or find out what the freezing point is. We're kind of like looking at it from the opposite side. In other words, we're catching the point at which the whole sample melts. Okay, I'm going to let this go for a little while, and then we'll see what happens. You'll notice here that the first few droplets of liquid have started to form, and I'm sorry I had to pull it out because I don't have a filter to look at what it looks like inside. And And at the end of the process, what you will see is it'll continue melting. And at that point, you would have placed, let's say, for example, let's say this was A. And now when I come in here, I can show you that it is fully melted. And I would have at that point hit, the second set in there. Notice that when you click that, it briefly flashed, L1, L2, or R1, R2. That means left, center, right. And I'm going to close out with this one here. And the numbers you're going to get, this is the fully melted sample. Let's see if I can get it to focus. And notice that as soon as I took it out, it starts solidifying again, right? It starts freezing again. Okay, so let's look at a sample set of data, what it would have looked like. Once you're finished, of course, in your case, you're not going to be pulling out the capillaries because I did it just so I could show you. You'll have to leave them in there. Once all three of the samples have melted, you can simply click the stop button, and then what will happen is it'll start cooling, and now your data light will start flashing. That means that you can now retrieve data that you recorded here. Remember that as you were going through the process, the person making the observation was telling their teammates, hey, melting A or melting B or freezing A or whatever. So they could write down the temperatures from the display. But at the same time, that person was clicking these buttons. So let's look at the data for the left side. Remember, this is your unknown. We're going to click it. Every click that we go here is going to toggle through 4 possible captures. Now remember, you only did 2, which means that probably the first one you do, nothing's going to show there because it didn't occupy that channel. So click it again and toggle until you find the first set that you captured. There it goes, 124.3. That would have been the melting point. That was when that sample began to melt, when you saw the first little droplet. And then if you click it again, it's going to show you 124.8. That would have been when the substance finished melting. We're going to call that the freezing point. Now you're going to do the same thing for the other ones in sequence, and you'll be able to collect those for the center. And like I said, you'll have to toggle through until you get these different data sets here, okay? All right. Okay, students, so we've done the experiment. Before we wrap things up and leave, we need to dispose of our waste. So we have several items of waste here. Number one, we have our capillary tubes. Even though the substances that we're using are really not toxic, we want to continue practicing good safety guidelines, all right? So you'll be provided with a waste container that says used capillary tubes. And what you're going to do is you're going to dispose of your used capillary tubes in there, all right? If for some reason one of your capillary tubes broke inside the machine, make sure you tell your instructor so that the stockroom manager can come and fix it for you. Okay, don't try to pull it out yourself. Don't try to disassemble the machine. Just let us take care of it, okay? The other piece of waste that you have is what is left on your watch glass, right? All that powdery stuff. So for that, again, we have another waste container for this lab, as you'll usually do. And so we want to open that. And what we want to do is, with your spatula, very carefully, kind of scoop it in there, sweep it in there. All right? Sweep all your stuff in there. And get rid of as much of it as possible. Okay, you might not be able to get all of it. Whatever's left in there that you cannot kind of sweep into the waste container, just simply bring it back to the sink and you can just wash it off. Like I said, these are not toxic substances per se, but we want to continue practicing good lab safety. All right. Okay, one more thing before we leave. Let me tell you this. Let's say that when you were doing the experiment, you put your capillaries in and one of them started melting before you even started. What that means is that in your mixture with your unknown, you put too much of the known compound. Like I said, the lab manual gives you a ratio of about, I think, 4-1 or 5-1 unknown versus your known compound. I generally recommend something on the order of 8-1 or 9-1. So if that happens, please just go and redo your mixture, repack your capillary tube, and now put it in and make sure that it doesn't work. Now here's our kind of rule of thumb. You only get 2 chances, all right? If the second time the sample melts again before you start, well, that in and of itself is an answer. In other words, that tells you something about that mixture you made there. In other words, it is not a pure sample. So you already have an answer. You just don't have specific values for the melting and freezing point, all right? So thank you very much. Let's go over a set of sample data and see how we're going to analyze and finish out our lab report.